A very warm welcome to all 10th standard students for the new session of chemistry. Here we are going to start with chemical reactions and equations, which is chapter 1 from your textbook. Now, what are chemical changes? Just to recap what we have studied in standard 9th, there are two types of changes, physical and chemical changes. But change in which a substance changes its properties and chemical composition is called a chemical change. For example, ripening of fruits, cooking of food, rusting of iron and souring of milk. So in this we can see they change their chemical properties. All chemical changes can be expressed in the form of a chemical reaction. A chemical reaction is accompanied by change of state, change of color, evolution of gas or change in temperature. So all these things can tell us that there is some chemical reaction going on. Chemical equation. Every chemical reaction can be expressed in the form of chemical equation also. So first of all, for a chemical reaction, it can be expressed as reactants give products. Reactants arrow products. Reactants and products are expressed as their chemical symbols, then it becomes a chemical equation. Burning of magnesium ribbon. For example, magnesium ribbon, when burnt in presence of oxygen, it burns with a dazzling white flame and white-colored magnesium oxide is formed. This chemical reaction is characterized by change in color and flame. So magnesium ribbon changes its color from grey to white color and then it is going to show the dazzling white flame also. This all prove that there is some reaction or chemical reaction taking place. The reaction can be expressed as magnesium plus oxygen, which are the reactants, give rise to product which is magnesium oxide, and it can be written as chemical equation Mg plus O2 gives you MgO, where Mg for magnesium, O2 for oxygen and MgO for magnesium oxide. Next example is reaction of zinc and acid. If hydrochloric acid or sulfuric acid is added to the pieces of zinc, hydrogen gas is evolved, which can be identified by a small blast with a candle when brought near to it. Here we can see in the diagram, hydrogen gas which is collected in the test tube and then it is passing through water. From water the hydrogen bubbles are coming up and they produce popping sound. So here the reactants are zinc and sulfuric acid. So we can write down the equation as Zn plus H2SO4 gives you ZnSO4 plus H2. Next example is reaction of lead nitrate and potassium iodide. This reaction is characterized by production of yellow solid, which is also known as precipitates in chemistry. Lead nitrate plus potassium iodide, which are the reactants, give you lead iodide plus potassium nitrate. The equation can be written as PbNO3 whole twice plus Ki gives you PbI2 plus KNO3. PbI2 is the yellow solid or precipitate. So initially both the solutions are colorless. As soon as they are mixed together, they are going to give this yellow solid. And this represents the reaction, chemical reaction occurring over here. Here we have to remember the formulas of all the components which are involved in the chemical reactions like lead nitrate, potassium iodide, etc. Next is balanced chemical equation. Now according to the law of conservation of mass, no atoms are formed, neither they are formed or destroyed, and no mass is formed or destroyed during a chemical reaction. So, the chemical equation must be balanced. That means the number of atoms on the left hand side or reactant side should be same as the number of atoms on the right hand side. Here in this equation we can see the number of atoms which are zinc, hydrogen, oxygen and sulfur they are same on LHS as well as RHS. That means this is a balanced chemical equation. But not all equations are balanced. So there are certain steps we have to follow to balance a chemical equation. Balancing a chemical equation. For example, this one, Fe plus H2O gives you Fe3O4 plus H2. First step in balancing a chemical equation is we are going to list down the atoms which are taking part in the reaction, that is here Fe ion, hydrogen H and oxygen O. The number of atoms present in LHS and RHS. So Fe we can see 1 and 3, hydrogen 2 and 2, oxygen 1 and 4. That means this equation is not balanced. Next step is to select the compound with maximum number of atoms. So here we can see Fe3O4 is the compound having the maximum number of atoms. Here, so we are selecting Fe3O4 and we are going to take one of the elements from Fe3O4, that is either Fe or oxygen. But basically we are going to select oxygen first. So we are going to try and balance oxygen on both the sides. If we see on RHS, O4 means 4 oxygens are present, while here on LHS only 1 oxygen is present. So we are going to balance by putting 4 just before H2O so that 4 oxygen atoms are there on LHS as well. Remember that we cannot change the formula of the compound. So we cannot write H2O4, but we are going to write 4 just before H2O. Now next step. Now we try to balance hydrogen on both the sides. So after oxygen we are taking hydrogen. Hydrogen if we see on LHS, 4 2s are 8 hydrogens are present. So similarly on RHS also we require 4 hydrogens. So we are going to put 4 over there. Fe plus 4H2O gives you Fe3O4 plus 4H2. At last we balance the remaining atom, that is Fe. So if we see on RHS Fe3O4 is present. So we require 3 Fe on LHS as well. So we are going to write 3 Fe plus 4H2O gives you Fe3O4 plus 4H2. Now we can see all the atoms Fe, hydrogen and oxygen are all balanced. You can try balancing different equations. Now, one more thing for chemical reaction is writing the symbols and physical states. For example, 3Fe in the bracket S plus 4H2O in the bracket small l gives you Fe3O4S plus 4H2G. So the subscripts or small letters in the bracket, they are denoting the states of that particular atom or particular compound. For example, if we write small s, represents solid state. That means Fe is in solid state and Fe3O4 is in solid state. If we write L, that represents liquid state. That means H2O here is in liquid state. While small g is representing gaseous state. That means hydrogen is present over here in gaseous state. Sometimes in the bracket small a and small q is written. That represents aqueous solution. That means the substance is in the form of solution in water. Now, most of the time the conditions are to be mentioned on the arrow. So conditions means sometimes the reaction takes place at a particular pressure or temperature or in the presence of sunlight or in the presence of some chemical. Then these all the things should be mentioned on the arrow. So first example, CO plus H2 at 340 atmosphere. So here we are mentioning the pressure over the arrow, which gives you CH3OH. The second example is CO2 plus H2O, sunlight and chlorophyll. So this is all the balanced equation for photosynthesis, which gives you glucose C6H12O6, which is in the form of aqueous state, plus 6O2 oxygen in gaseous state plus 6H2O in liquid state. This is how the conditions are mentioned on the arrow. So last is our worksheet. I would like you to practice all the formulas which we have come across during this session, like sulfuric acid, hydrochloric acid, barium sulfate, which is given in the question in your textbook, lead nitrate, potassium iodide, aluminum sulfate, sodium hydroxide, sodium sulfate, hydrogen gas, and magnesium oxide. So please go through the 9th standard chapter where the valencies and how the formulas are made in chemistry, because that is very, very important. And come back to me for any queries. You can just leave a message on my personal number. Okay, thank you.